Well, welcome to our CO232 Linux administration class. Finally, I see you all. Welcome. It is a little bit late, so we'll do what we can to stop you from falling asleep. But in fact, Linux is such an exciting subject that I'm sure that we won't have any trouble doing that. Today we're going to go through week 1 and week 2, which is not a problem at all. Both weeks are fairly slow. We did, I think, work out some of the textbook issues. I want to make sure that everybody can log in through labconnection.net before leaving class today. All right. My name is Szymon Machajewski, and I'm one of the full-time faculty here at GRCC. I teach classes anywhere between programming, through databases, through Linux administration, as well as the Apache administration class. So if you have any questions about how the other technologies fit into Linux, feel free to ask, and we'll look into that. This class for this semester was adjusted to make sure that our curriculum fits the Linux Plus certification. Okay, so if you're interested in taking Linux Plus certification, and there are 2 exams involved, let me know. We actually get a discount on the exams if you buy the exams through the college. All right. The exam is not very difficult. It assumes that you have gone through the curriculum and then that you've used about Linux for about 6 months. Okay, so if you've used Ubuntu, if you've used any of the other Linux systems, you should be okay. You should be ready. All right. I'd like to start today by just quickly running through what we have in Blackboard about our course. Okay, and then we're going to start our installation lab, which is in week 2. And in between, we'll talk about Linux, just a little bit of an introduction about Linux. Before I go on, are there any questions at this point? Okay, great. So in Blackboard, you should be able to go to My Blackboard and then select the 8168 section. Here you'll see some announcements, as well as a little billboard that's actually here in Grand Rapids about Linux. I want to tell you that open source in general is a great field to get into. Linux or Unix is a great way to invest your intellectual property, to invest your time. The same commands that were in use in the 80s with Unix are still used today. Okay? So if you've learned Unix years ago, your skills are still current, which is great. You can't say that about other operating systems, because if you've used Windows 98, okay, today it's different. If you've used Windows 3.1, most of your skills are not current, right? So that's the nice thing about Unix, that those skills last. So let's take a look at course information. And under course information, we have an important document, the syllabus. Let's briefly look through the syllabus. In this document, we have just a brief description of the course. We have the textbook information. As we go down, you will know how to get a good grade in the class. The online labs that we have are very important, because that is very much a hands-on time that you spend with Linux. Okay? We also have regular tests. We will have some projects, and then the final exam. Other policies associated with the course are fairly standard. This is likely not your first class at GRCC, so in terms of tutorial labs available and attendance policies, those should be fairly standard. All right? Any questions about the syllabus? Excellent. So we'll go ahead and move on. We have the schedule for our class. This schedule helps you to see on each date what it is that we'll be discussing. So today we have week 2, and like I said, we're going to work through both of them together. But if you miss a class, you know what's coming next. And then the detail for each week is, of course, under assignments in each of the folders for the week. Okay, so that's how the class is going to flow. That's how you know what to expect. These titles under weeks correspond to chapters in the textbook, right? So my expectation is that you read the chapter ahead of time, and then you come to class, and then we can discuss the chapter, and then there's usually a test or a quiz, and so then you can take the quiz after we've discussed the chapter, after we did the lab, okay? Because I know that you're excited about Linux, and our discussions will be long, likely you'll have to take the tests at home, okay? Unless discussions are short, and then we'll make sure to have like a closed book test here in class. All right. All right, excitement again, great. So let's look at week one. Week one is actually introduction, a very really historical approach to Linux. If you've read chapter 1, and I hope that you have, it gives you a lot of information how Linux came about, right? How is it that we have something called Unix, something called Linux, and how are the licenses working and so forth. I encourage you to view this video right here that's actually based in Drupal, which is another open source product, but they really explain how open source fits into software development. And it's really a different way of creating software. There is a well-known book by Raymond called The Cathedral and the Bazaar. And if you like reading books, you can take a look at it. This book is available online in HTML form and through PDF, so you don't have to buy the actual book. But basically, Eric Raymond in this book explains that some software in the commercial world is created like a cathedral. Okay, so what you do is you have a few developers who in secrecy go in, design things. They're the only ones that know how it works. And years later, you have the grand opening and you have a new version. Okay, and then to fix it, you bring the same priests, you know, and they do whatever they do to get it working again. Whereas another way to build software is very much to do it like on a bazaar, where everybody brings something in, everything is out in the open. Okay, you bring something in, you move it somewhere else. You can very easily split projects, and so we call them to fork a project or to create two different projects out of one. There's a lot of collaboration, a lot of people involved, and basically the software continues to be built as you are using it. Different way of doing it, okay? And there are certainly benefits to doing it the open source way, to release often, to have a lot of eyes on the code. There's a saying that many eyes make bugs shallow in software, all right? So some benefits that way, and I encourage you to look at this book because it deals with the fact that open source is more than just a technology, that it's more like a movement. Because open source today not only affects software, it affects licenses. Have you heard about Creative Commons maybe? Okay, so it affects licenses. It affects artwork, okay? Today, after we install our first Unix system, we'll go to art.gnome.org, which is a repository for artwork that is licensed flexibly. Okay, that's licensed just like open source software. All right, textbooks or books in general and licensing of books under flexible licenses. Okay, all of that is really a movement of people wanting to share what they've created and finding ways to make money not just on licenses but on services around those products. See, a completely new approach. And the reason why open source is a great business to get into is because for years now, IT offices were trying to save money. And the way they would do that, okay, is very simply with a pencil and paper. And if this product you have to pay $50,000 yearly for, and this product is free, then this free product must be a better financial solution. Well, open source is better for more than just the price. It's usually more secure, it performs better, more customizable, but it's the bottom line that caused many in the recent years to go to open source products. A great example is Blackboard versus Moodle. Okay, Blackboard can be an expensive product for a school to maintain. Moodle is free. Well, must be better, right? And so a lot of schools made that switch just based on the price question. And so what they find out after a few years into the project is that they need more people to maintain the open source systems because customization costs, because suddenly you don't have a company behind the scenes that's ready to answer the phone call and provide a new patch or a security fix. So now they find out that whether it's Linux or any of these open source solutions like Drupal, they need people to maintain it, which is why it's such a great job opportunity and industry to get into. So if you have opportunity to polish and learn new open source skills, there's always a market out there. Let me give you an example. I already mentioned Drupal as a software. It's software to run websites, basically. And CO231, we deal with Drupal in that class. But if you look at jobs for Drupal, notice the locations, okay? Let's just go down here. We have, these are the most recent ones. But here's Barcelona, Sweden, China. All right, so people all over the world are using open source systems and realizing that, hey, we're going to need people. Okay, and this is why, again, looking into open source is great. This class talks about Linux, which usually is the environment. If you think about a developer or a programmer creating a program, they really create a way to behave inside of a system. The operating system, like Linux, is the universe. It creates the entire environment. This is where the files are going to be saved. This is where the memory is managed. This is where the CPUs are running. So you would be in charge of the environment. And so that open source environment is often very, very important not only for new things, but to keep other things, old things running well. Okay? All right, so that's just a few words about that. Actually, let's very briefly, let's look at this one commercial. It's through IBM. And let me just say this about IBM, that Linux started in early 90s in Finland, right? The student basically came up with this project, and this was a version of Unix. Other Unix systems were very expensive. HP had their Unix, IBM had their Unix, was called AIX, and then there was HPUX. Sun Microsystems had Solaris, expensive systems that usually were sold with hardware at the same time. Just like today, you buy Macintosh, okay? You buy the hardware with the software at the same time. So those systems were very expensive because of that. Now, what we saw with Linux was that suddenly, Linux could run on all kinds of hardware pieces. So just like with Windows and the personal computer, we now had competition for hardware, which meant that hardware became less and less expensive. Okay, a huge change in the industry. But it was really thanks to companies like IBM who invested a lot of money into Linux to polish it, to make it a commercial product, that Linux is a success as it is today. One thing that happened to Linux which was really groundbreaking was when Red Hat, which is another company that figured out how to make money on Linux, Red Hat slowed down the development cycle for Linux. They said, we will not release a new version for 6 months. Before that, Linux would have new versions all the time. Why slowing down? Why do you think the slowing down of development cycle would help Linux?
Some updates and everything, doing it where they got it like scheduled, kind of like around 6 months, can actually help it out instead of just having to download something every couple of days.
Okay, all right. How else do you think that that making the 6-month versions, how else does it help?
Standardization.
Standardization, okay, okay. If you are a hardware company like IBM, you want to have some time to say, hey, this hardware is now compatible with this version of Linux. You want to have some time to do that. So now you see HP, IBM could certify that this version of Red Hat will run on our hardware. Software companies, even more, like Oracle, a big database company, they could say, hey, Oracle now can run on Red Hat version 2. Without that, you see, Linux was changing so quickly that it was more like a hobby project than a commercial product. You see, so those things made Linux a commercial-grade system. And let's just take a peek at this commercial because it brings some other important things about Linux. Whoops, sorry.
A story is told about an orphan, a boy who belonged to no one. But the boy was not alone. He had friends. He grew fast, and everyone who worked with him worked better. Because the boy who belonged to no one had been adopted by the world.
All right, so in this set of commercials, why do you think that IBM paid, and I'm sure they paid a hefty price, why did they choose a little boy to represent Linux in this commercial set?
Potential for growth.
Potential for growth, all right, very good.
Kind of new, kind of recent.
Kind of new, okay, yeah. Anything else you can think of?
Constantly evolving.
Constantly evolving, all right. Did you notice they mentioned it's learning globally. It's learning everywhere. See, because the source for Linux, the source code is available globally. So people in China, people in Russia, everywhere there are scientific clusters, they can add to it. They can modify it. But think about a child being teachable, okay? That's what makes kids unique and have curiosity, not being afraid to step into something new. Well, a commercial operating system, how can you change it, right? How can you teach something new to a system that you really don't have much access to, right? So here we're talking about this Linux system being very customizable. Everything is open. You can make modifications, which has potential. And that's great. And IBM, being a very, very solid company, recognizes that even now, Linux is at its beginning. They make a lot of money on it, all right? Let's not kid ourselves. What they're doing is basically selling inexpensive hardware with free operating system as a solution, okay? And in today's market, it's a great way to do business, all right? And so So IBM got behind Linux for that reason. So yeah, it has all the features of a project that can add a lot of benefit globally to knowledge that people in general have. So that's why I appreciate Linux, and I included a few links here at the bottom in week 1. By the way, let me straighten out something immediately. In lab 1, there is a question which you all, or most of you, got right about the kernel. Okay, anybody remembers what the kernel is? What's a kernel? Yeah, so not only in Linux, but in other operating systems, you might be familiar with a kernel error message from other operating systems. So a kernel is like the main program that talks to the devices. And when the kernel dies, then the whole thing goes bad, all right? But in addition to the kernel, the operating system will have other programs that can be started and stopped. The kernel itself will always be running because it's the operating system itself. So in Unix we have, or in Linux, we have kernel designations. The first number is the major version, which we are up to version 2, right? Then there is the minor version, which basically can be either odd or even. And if it's even, then it's a production strength software, which means people tested it. It does not have any experimental stuff in it. You can use it in production. So 2.6 would be a production kernel. And then the last number would be the current build, and those numbers would change very quickly. In lab 1, one of the questions actually asks about kernel 2.6 with change, and then it calls it development, right? And so many of you have noticed that. So if you get that question wrong, it's okay. You still get 100% in Blackboard for that. So that actually gives us a good point of reference to examinations, and that is when you take the Linux Plus test or any other certification examinations, try to think not just whether the question is right or wrong, or but what the people who wrote the question were trying to ask you. Okay, sometimes you'll have 2 right answers, and you have to choose the one that is better. When the question is messed up completely, like ours, okay, then there's nothing you can do, because you will answer the correct answer and you'll be marked down wrong, which is why it's so important to get all the questions that you can correctly, so that you can offset some of that margin of error in the wrong questions, in maybe your mistakes and so forth. So it's a good lesson in testing that you don't want to, even if it seems that the test is very easy, you want to make sure to get all the questions that you can correctly, because there's always going to be a margin of error. All right. With that, let's go ahead and move to week 2. And in week 2, we are all about the installation of Linux. And installation of Linux is the easiest thing that you will ever do. Basically, you press the next button quite a few times, all right, and you're done. But as a level of difficulty, what we will add in our class today is virtualization, okay? Because I'm trying to avoid a situation where you take the CD from the textbook, you take it home, you put it in your main computer in the house, right, that everybody is using to go to md.com, diagnose yourself and so forth, and move your money on your accounts. So you put the CD in, then you restart the computer, and you start a Linux installation, right? And you overwrite whatever was there before, and suddenly people start losing their documents, and your family, you know, comes over here to talk to me to see how many weeks it'll take to fix it. So don't install Linux on your main computer at home. Not that it's not going to work, okay? But there's just a lot of things that can go wrong. Now, some people choose to try to do what's called dual boot, which can be done. And dual boot basically allows you to take your C drive, resize it, so that you have spare space on the disk, install Linux on that second part, and whenever you start the computer, it'll ask you, would you like to boot into Windows or Linux? Okay. Don't do that. Because again, there's many things that can go wrong. The best way to learn a new operating system, whether it's Linux or any other one, is to use virtualization. Virtualization today is freely available. Not all of it is free, although in Linux we have virtualization called Xen, X-I-E-N, and you can run it on Linux, and it's open source. We also have free virtualization called VirtualBox, and it comes from Sun Microsystems, later bought by Oracle. So if you are using a Macintosh computer, you can use VirtualBox for free and install Linux on that. And then you have VMware, which is the oldest virtualization, and really they have the most experience. I believe that they really are still the leader in that market with all kinds of tools with virtualization. And so they have a free product called VM Player. If you would like to install VM Player on your home computer, you can go into a virtual machine folder and just download this executable. Okay? You want to do it correctly, you go to vmware.com, you have to sign up for their account, then get it like an email ticket, and then download the software. Okay? It's up to you. You can have it either way. But if you just download the executable from here, it'll work as well. And the resulting program is going to basically look like this. You'll go to vmware.com, VMware, and VM Player. Okay, this is what VM Player looks like. And again, it's free. It is not open source. Okay, let's just say that right away. It's not open source. So at this point, what I'd like you to do is go ahead and open VM Player. And what we will do is we'll create a new virtual system. Okay, inside of this computer that we have on top of our desks, there is power supply, CPU, RAM, main board, all kinds of connectors, IDE and others. All of that is hardware. With VM Player, we can create a copy of all the hardware only through software. It's virtualized, which is beautiful because suddenly you can have multiple CD-ROMs, or you can have multiple network cards, or you can run two systems on a single box and then see how two servers would act with each other. Okay, so virtualization is a beautiful thing. So to start a new virtual machine, go to create a new virtual machine, a big button at the top. Next, it's very important that you select, I will install the operating system later. Okay? And then we'll go ahead and say next. Now we have options for different operating systems. Let's drop down version and choose Fedora. There are two options for Fedora. There's Fedora, which is 32-bit, and Fedora, which is 64-bit. That's another beautiful thing about virtualization. If you have a 64-bit CPU, you can create either a 64-bit system or 32-bit system. I mean, just great. You can experiment with systems. You can install Windows into those virtual machines. So you can have Internet Explorer 6 and Internet Explorer 9. Right? If you're a web developer, you know that sometimes you wish you had multiple browsers like that. Okay, so we'll select Fedora, the 32-bit system. So just Fedora all by itself. For us, it doesn't really make that much difference which Linux you select. Okay, VMware does try to optimize the hardware. But for Linux, as long as you selected Linux here at the top, it's fine. We'll say next. And now we're going to choose the location of the virtual machine. So the best place to put this virtual machine is on the C drive of your computer under a folder called VM Images, and then make sure to create a new folder, okay? And so the best way to do it here is to say your first name and then Tuesday. So use your first name followed by Tuesday, and this is going to create a new folder, and your virtual machine will be on that folder. So it's important that you sit in the same location next week. Okay, that way you'll be able to use the same system. By the time we are done, this folder will have about 4 gigabytes of data. If you have a USB drive that's big enough, you can actually copy this virtual machine, take it home, and just start it at home. Right? Not a problem. But if you have a smaller one, then just be aware that that's the minimum of disk space you'll require. Great. We'll say next now. Here is where we will define a new disk. You can't have more disk than the actual disk in your drive. Okay, so let's just say that right away. But if I say that I would like to have 20 gig disk, it's not going to take up 20 gig of my space. What's really neat about the system is that it'll only take up as much as I'm installing at the time. So first we will only create files for about 4 gig. And then as we add more software, then it'll start taking up more space. You can always shrink it later, okay, and there are other options. It'll actually do compression, so it's fairly efficient. So 20 gigs is just fine, and we can use a single disk because we are using NTFS, so that allows for large files. We'll say next. And with a quick review, this looks great. We'll say finish. So now we have an empty new hardware. Basically, it's an empty disk. It has a CPU on it. In fact, if you click on Edit Virtual Machine Settings, you'll see that you can modify some of the hardware elements later on. If you intend to take this virtual machine home, make sure that at home you look up how much memory you have. Okay, these machines here have what, 2 gigabytes? Well, so to check it, you just go to Computer Properties. 4 gigabytes. Okay, so we have 4 gigabytes, 2.8 usable. That's 2 thumbs up for Windows for limiting the use of memory here. So there's memory. If at home you only have 1 gig, it's very important in virtualization to leave the host. So the host is the main computer, guest is the virtual system. It's important that the host computer has enough memory to do its business. Okay? If the host computer has problems, then nothing will run well. So it's important that the host has enough memory. So if you have only 1 gig, you may need to change that and maybe set Linux to only have 512 meg. It's plenty of memory for Linux with 512. Okay, it's not a problem. But this is how you would do that. Okay, what are we missing at this point? Can we install Linux now? What's that? We need some media. That's right. Linux can be very flexible on how it is installed. For example, you can install it with a CD-ROM, and there was one that came with your textbook. I think it has Fedora 13. Not a problem. If you would like to use your CD-ROM, at this point, just go ahead and put it into the CD drive. Okay? Yes, yes, yep. And there's no license code to track, so that's good. Or, using virtualization, we can tell the computer that our CD-ROM is somewhere locally on the disk. Let me show you how to do that. If I go to Edit Virtual Machine Settings, click on CD-ROM, I can say use an ISO image. And now I can browse. On your computers under C drive, there should be a directory called ISO, and there should be a Fedora 14 file. If it's not there, then just use the CD that came in your textbook. You see, virtualization is so beautiful that it allows me to fake a CD-ROM. And then that's great because I can download now, multiple versions of Linux. Yeah. Another way to install Linux is by placing all the installation files on a remote server. Then you can put in the installation CD, and you can specify my installation is on this server, and it'll install from the remote server. It's a great way to standardize your installs, and it's actually very fast doing it that way. You can install off USB and even off the local drive. So let's say that you had installation of Linux on a partition. you could install from there to another part. Okay, so now that we've specified the CD-ROM, or now that you have put in the CD-ROM in the drive, we can start the virtual machines. Let me say this, that this virtual machine is going to act exactly like the hardware machine, which means that this virtual machine has a BIOS of its own. Anybody knows what BIOS stands for? Yeah. Input-output system, yeah. So BIOS is a little program that allows you to set what's my bootable drive. Should I boot from CD or the local disk? You can modify all that in the virtual machine. You can change the clock settings, all kinds of things. Let's go ahead and start that. If you see errors about, like this one right here, it's not an error. It's just notification about virtual tools. Just say remind me later. We actually don't have access on our systems to do anything, so we just say remind me later. All right, so now we actually are booting right off of our CD-ROM, whether it's virtual or real. And the first option is to install a new system. The second option is to install a new system with basic video driver. Then a very important option, a rescue installed system. If at some point your hard drive goes bad and some files get corrupted, you can put in the CD back, say rescue installed system, and it'll try to override files that are wrong. You can also try to go in, if you got hacked for some reason, you can go in and actually look at the hard drive without modifying it. Okay, so the rescue option is great. Boot from local drive just means, skip the whole installation, and then there's memory test. Well, mine kicked in automatically with the first option, which is just fine. Okay, and so at this point, I have the option to test the media. Okay, please don't test the media. It's going to take us a little bit of time. The only reason really why you want to test the media is when the first time you downloaded a new version of Linux, you burned your own CD, and you're just not sure if it has all the files placed correctly. Or if you ran the installation and something isn't running correctly, and then you want to make sure that you test the media. But for us, use the tab key and you can skip it. Okay, use the tab key. A quick lesson on the VM player. Notice that I can't move my mouse right now. The mouse is gone. The mouse is actually inside of the virtual machine, but it doesn't have any visual cues. So if you press Control-Alt, and it does say it right here in the corner, but when you press Control-Alt, the mouse will jump out of the virtual machine. If you want to operate the virtual machine again, you click back on the blue spot or on the screen, and now it's inside. So the tab key now works for me just fine. I'll go ahead and skip. I'll skip the testing. All right, let me walk through and make sure that everybody is right around that area. Were you able to start the virtual player right here?
Yep. I just don't. I'm looking for Fedora right now.
Oh, do you have the CD-ROM that came with the textbook? Okay. Are you using the CD-ROM? Could we borrow yours for a second? All right. By the way, the Fedora system that we're using in this class is related to Red Hat. It's like a preview of what happens in the new version of Red Hat. Thank you very much. Go ahead and put that in the drive and start it up. So the reason why I love Fedora is because Red Hat is the enterprise leader, really. So most databases, most systems require Red Hat. And Fedora just keeps us really close. So the same tools, and it's freely available. So you can use it at home and on servers as well without a problem. There are other distributions like Debian. There is Slackware, Mandriva, all kinds of other distributions. But because Red Hat is sort of the core commercial product, I like to stay close to that. CentOS is another type of a Red Hat system. Okay, but just want to let you know why we're using Fedora is because it's a very much close to commercial life.
So it's Red Hat is pretty much the same thing with Fedora.
They are related, yes, which means that the same tools are used, and programs typically behave the same way. So what you learn in Fedora translates into Red Hat really easily. Yeah. Question?
Red Hat is very similar. They 1% of radio.
Yes. So here at GRCC, we use Red Hat extensively. Red Hat was really the first successful commercial Linux, and primarily because companies like Oracle and IBM stood behind it. And basically, when you buy an IBM server today, they'll say it's compatible with Red Hat version such and such, and they will actually pre-install Red Hat for you if you want to. Yeah. Now, Red Hat is very expensive. It's about $2,000 a year to run at home. Okay. But we'll talk about why it still makes good sense and why it is that we call it free operating system. So we'll get there. Yes, question? Yes, DistroWatch. It'll give you all kinds of other distributions. In the CO246 class, we use Knoppix, which is a Debian family, and it allows you to run Linux right off a CD without a hard drive in your computer. Yeah. Question?
I just tested the NVIDIA.
Yeah, Ubuntu is a little bit different family, different distribution. Is also the Debian core. Yeah, and huge differences in the way that some software is not open source, unfortunately. Okay, ATI and NVIDIA, being video vendors, they do not allow their software to be distributed with open source pieces, and they don't provide an open source version of their software. So Fedora does not include, or Red Hat do not include, the NVIDIA or ATI drivers. They will have their own basic driver that will work. Like you'll see the screen, like 800 by 600 resolution, right? But to make NVIDIA work, you have to go to NVIDIA.com and download from their website and install the binary version. Fedora and Red Hat stand by the legal aspects, which are unfortunate. The other thing is the codec for DVD playing. Okay, not legal to distribute on Linux systems. What else? Wireless drivers. So Fedora and Red Hat are very much commercially minded, so they do not distribute that. Ubuntu, different. Okay, basically what they will do is they will host those drivers and software on other countries' websites that are not so concerned with some of the legalities, and which means that someone who's installing Ubuntu can play DVDs right away. Their wireless stuff works perfectly, okay, and their video works great. But that's because it's really more for the end user, for the desktop, whereas Fedora and Red Hat are more for the back-end commercial installations of the operating system. Yeah.
Ubuntu, I think, shows a message about the drivers.
Okay, what does it say?
It says something about they're closed source.
Okay, I'll click here to use it. Yeah. Okay, well that's good. Okay, great. So we're on the same page. Excellent. Excellent. All right. So you can see how easy installation of Fedora is. You have only one button to choose from, right? I mean, that's my kind of level of complexity. So we'll go ahead and select next, because out of the available options, that just seems like the best one. Okay, now you can choose the language, and we're going to use English. In other countries, most installations are also in English, because when you Google your error message, right, you have more chances of getting the right answer when you do it in English. So it sort of becomes the status quo language of Linux. So we'll say next. Now, US English as it relates to the keyboard layout. And so we'll choose English for that as well. For security reasons, once I detached all my keys from the keyboard and plugged them in back randomly. Okay, I actually can type without looking at the keyboard, so it wasn't bothering me, but I felt that my workstation was more secure, that way. All right. Two options. We can do specialized storage or basic storage. We will choose basic storage because we have a local disk, which is the most common installation. If you have a SAN, which is a storage area network, or a NAS, network area storage, you can use iSCSI or you can use fiber channel, which are different ways of connecting the hard drive. Imagine that you would like to have your computer run on this computer, but then save all the files on the other computer. You can start an iSCSI server here, create a target, and then whenever I try to save a file on my computer, it actually will travel via Ethernet, either wireless or wired, on another computer. This is very useful if you do something called RAID, where you're going to mirror your files on multiple systems. So with iSCSI, you can save your file on multiple computers all at the same time. So that helps with then recovering from disasters and problems as such. So during installation, you would have to provide that. This is different than later on. Once we install on the local disk, you say, I would like to have a shared drive here of some kind, or I'd like to have an iSCSI attached. You can still do it later on for additional drives. We are deciding where our main operating system will be running, and that is usually best done on the local drive. So basic storage is what we want to choose. We say next. Now we see this little error message, which is not a problem. The installer is really good at letting us know and putting us in the driver's seat about any changes that will take place on the disk. So right now it says, I'm going to do something fairly serious. I'm going to delete all your data. Okay, so are you sure you want to do that? And it's nice of them to do that, to say so. We are using a virtualized disk. We are not overwriting the entire C drive. We are preparing this virtual disk that right now is at 0 bytes, and we're going to format it and do other things to it. So this message does not mean that you're losing all your pictures and you know, possibly your family's music, right? We want to preserve that. Yes, reinitialize all. Yeah, reinitialize all. That's the button, reinitialize all. Now it's time to choose the host name. Please use your first name as the host name. At this point, it doesn't really matter what we type in here. Host names are managed by a service called DNS, Dynamic Name Services, and what you type in as your local name is not going to be recognized until DNS registers it, and then other people can call your computer with that name. But because we call it locally something of our own choice, it really doesn't matter at this point what we typed in. We can always change it later too. So we'll keep it with our first name. We'll continue. And now the fun part, you get to choose where you want to live, right? So there is Detroit. If you select it just right, there's Detroit. You can select it from the drop-down as well. New York will work just fine. It's all Eastern time zone, right? The important element is here. The system clock uses UTC. We are going to uncheck it. In today's version of virtualization, VMware specifically, it doesn't really make that much difference. But in previous versions, if you didn't uncheck that, the hardware clock that's on your motherboard and the clock that was virtualized, they would fight with each other, because each one tries to keep a heartbeat of the system, okay? And when there are two of them, there were problems. So when you uncheck the UTC, then the virtualized clock basically is more flexible. Our clock will be always wrong, which is okay. The reason why it will be always wrong is because instead of shutting down our virtual systems, we're going to put them to sleep. And so then when we resume, they'll think it's last week, okay? Which is okay. So just want to let you know that we're flexible on timing. Say it again? Is Grand Rapids a choice? Awesome. Grand. No, I don't see Grand Rapids. Knox. Oh, wait a second. I got a plus here. Okay, now I'm getting there. Okay, so Indiana, Detroit, Chicago. See, I don't get Grand Rapids. Did you get Grand Rapids? Is that what you said? Okay. All right. Yeah, so basically, not every city gets to be on the map for good or bad. It's the time zone issue. Yeah, time zone. We'll say next. Now you get to choose your root password. Root is the super user, the administrator. Okay, you don't get to choose the name of the user. It's always root, R-O-O-T, but you do get to choose the password. So go ahead and choose the password that you can remember. Don't choose the most secure password that you ever thought of. Okay, I'll show you later how to reset the root password, but we just want to choose a password that you'll remember, and we're not going to have a problem using. This is a development environment, academic environment. I'll say next. An important message comes up saying that my password is too easy. And we learn the first thing about the root user, and that is, it's the master of the universe. If the root wants to make a mistake, the system will allow that to happen. So I'll just say use anyway. If you are any other user, you cannot do that, right? But if you're root, then you can make all kinds of mistakes. Okay, our next choice is going to, again, be about the hard drive, and we can use the entire disk. We can replace what's currently on the disk. We can shrink the system. If you want to do dual boot, so you can shrink the system right from the installer, which is a great option. Before you had to use something like Partition Magic or QParted, different programs that allow you to resize your disk. You can say use free space or then create a custom layout. And so, so what we will do is we'll go ahead and create a custom layout. Okay, let's go ahead and do that. Create custom layout. That way we know what's taking place under the hood. And let's go ahead and say next. Now we have an empty disk, and our disk is called SDA. Okay, our disk is called SDA. We are going to create partitions. We have an entire chapter on partitioning, but just to let you know ahead of time what it is, if you think about the C drive, okay, being the disk, sometimes maybe you've noticed that when you download a lot of movies or you download a lot of MP3s, it can fill up. And what happens to a computer when the disk fills up? Yeah, so all kinds of bad things happen, right? So we try to design the system in such a way as to make filling up of disk space impossible on important partitions. So if we have a partition for the user to play with, then they can fill it up, not a problem. Because they fill it up, then they call us, then they have to apologize, which feels good, right? And then we do something about it. But on the operating system partitions, it's important that we size them in such a way that the users cannot fill them up. That's true for most systems which are interactive. So if you're going to have a system where many users log in, then you need to set partitions really carefully. But if you're running a database, if you're running a web server, then the disk space that you have on the system is going to be really managed by the administrator. And it's not like someone's going to just fill it up by downloading unused or useless files. So I'll show you how I usually install systems that are servers for non-interactive use. So servers that are web servers or databases. So the first thing that we create, and so you select the free space, then you press create. The first thing that we create under standard partition, we're going to create a swap partition. Swap partition, in Windows it's called the page file. And basically what it'll do is it'll allow us to copy things from memory when we run out of memory, which happens sometimes often. The rule of thumb is to use twice the size of memory. So anybody remembers how much memory we had? 1 gig, yeah. So for this virtual machine we had 1 gig. So technically we should put in 2 gigabytes of swap. And so we can do that here. This thumb rule about twice the size of RAM is true up to 4 gigabytes. If you have 10 gigabytes of RAM, then putting 20 gigabytes of swap is going to be a little bit of overkill, because by the time you have 20 gigabytes of disk space used by something, whenever you start copying that, it's going to be forever. So it's sort of useless. So for smaller memory sets, it's twice the size of RAM. Once you get to swap of about 8 gig, you may as well keep it at that. Fixed size is fine, and we'll say OK. And that's our first partition. Let's select the free space again and say create. Standard partition. Our next partition is going to keep the kernel. So the kernel is the most important program, and it's going to sometimes have many versions. And so we'll go ahead and select a boot partition, /boot. /boot is going to keep our bootable software. It's going to be a separate partition for that reason. And we'll go ahead and select, let's select 500 megabytes. That's a good size for a boot partition. Under file system types, notice that we have things like ext2, ext3, ext4. Those are core Linux file system types. They're great. All of them are great file system types. The improvements between 2, 3, and 4 have to do with journaling, and we'll talk about that later, and some performance. It just depends on the size of the files. So ext4 is a fine choice. We'll go ahead and go with that. We'll say OK. Now we have swap and we have boot. Let's select the free space, say create, and the last partition that we'll create is the root partition. Notice that earlier we talked about root. What was the root thing that we talked about earlier? System administrator. The word root is overloaded in Linux. Multiple things are root. The super user is root. The beginning of the file system is root. Okay? And then there's also the home directory for the root user called /root. Okay? So you'll get used to the differences, but when we say root of the file system, that's what it is. It's just a single slash. And that is where the operating system gets installed, and that's where most things are going to be running from. So what we want to do here is we'll say fill all space up to, and let's leave ourselves 500 megabytes. And the reason why we're leaving 500 megabytes is that in the future lab, when we play with file systems and partitions more, we want to be able to create additional partitions. And so we need a little bit of extra space on the disk. We'll say OK. Well, I don't know that that worked for me as well. Let's see, what did I do wrong? Fill space up to 500 megabytes. OK. All right, that's fine. So this is the design that I would use for a server, because it's sometimes difficult to predict how much separate space on a separate partition I should have for my database. Okay. Plus, most often today, when you run a database, you're going to mount it from a SAN, or storage area network server. So it really doesn't matter how much of the local disk you've dedicated to the database. Okay. So that's why this seems to be a very flexible design. This is not something that you use if you're going to have an FTP server that users store files on. If you're going to have an FTP server like that, you're going to create a home directory that's separate, where you specify this is how much users are allowed to use. All right. With this in place, we say next. And again, it says, hey, I'm going to do something to your drive. Are you sure? And the answer is yes. So let's format. And write changes to disk. If you're saying whoops by now, it's not a good sign, all right? Because with the formatting, stuff is just getting overwritten, and there's no coming back, basically. Okay, the next screen simply says we're going to have a single operating system. If you're doing dual boot, you'll actually see a next row here for Windows. All right, and so this is the bootloader. That's what's going to manage what we boot on this particular workstation. This looks perfect. Let's go next. All right, and this is where we start selecting software. The beauty of Linux is that licenses are typically not a problem on Linux, which means that you do not have to go to a vendor's website to download the exe file while installing, put in a license code, which means that most Linux distributions will have repositories. Basically, they are the entire selection of software that anybody would ever want to run on the system, and then you just select, I would like this, 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 and that. And then when you upgrade your system, you get connected to a different repository that has software compatible with your new upgraded system. So the software is stored on the cloud, and you just download it as you need it. A really beautiful way of doing things. So you just issue a command on Debian, you say apt-get install, and you say Firefox, and it just comes down. Or on Fedora, you say yum install Firefox, and it installs. So during installation, you have the option of creating a new repository or enabling ones that are already in place. Adobe has a repository, Google has a repository, so for all the additional software pieces, you can hook in to a repository of software. At this point, let's click Customize Now. Okay, we'll customize now and we'll say Next. We are connected to the local repository on the CD drive, right? Not internet one, but the local one. So it's very easy to add software at this point. You have a little button for optional packages. This gives you a great detail of adding options to a specific software type. GNOME is basically a desktop environment. It defines, like your start button, defines how the desktop works. You can select the other one, the KDE. Let's keep it at GNOME just so that we're on the same page with that. You can look through the various software pieces that are available. With any of them, you can click on the selection and then say optional packages, right? And so that allows you to see in great detail what it is that you're installing. What I want us to add is under servers, I'd like you to check server configuration tools. In some of our labs, we might need some of those optional packages. So server configuration tools under servers. Yep. All right, and with this selection in place, we'll go ahead and say Next. From here, notice the dependency check. Does anybody know what dependency is? Go ahead. Perfect, yes. So if you're a developer, you don't develop a software from scratch. You typically are going to take libraries that have already been prepared, and then you build off of that. So if you select a piece of software, there's a set of dependencies that are required for your software to run. In the past, it used to be pain on Linux to track those. But today, we have great databases that track all of them. And so when you say, either during installation time or later on, when you say, I would like Firefox, it'll go, okay, what are the dependencies? And it'll download all the dependencies that you need first, and then install your software. So it's really, really nice how that's done. All right, so now that we have a moment, let me ask this question. What is the difference between Unix and Linux? What would you say is the difference between Unix and Linux? Please. Yeah. Okay. Yeah. So proprietary system. That's the point. So what are examples of Unixes? What Unixes have you heard about or worked with? Solaris. Yep. Although now we also have the Open Solaris version, which is open source. Yeah. But the core Solaris was proprietary. Yep. Any other ones? IBM has a product called AIX. They still sell it, and again, you have to have specialized hardware to run it from IBM.
HP's thing?
HP UX, yeah.
BSD.
Okay, now BSD you see is a Linux type.
Now.
Now, right. Yes. So the key is that Unix relates to a proprietary system that is licensed, and you only get the compiled version of it. Whereas Linux is a Unix-like operating system that typically is available with the source code. Okay, so the key expression here is the source code. Source code is what C++ programmers, Java programmers, and other programming languages folk develop. It's the humanly readable code, and then you have to compile it to get binary executable code. If you have a 32-bit processor, you compile source code into 32-bit executable. You can't run that executable often on another CPU. So if you're running it on Intel, you can't just execute it on Motorola, right? So when you compile the code, you will compile on a 64-bit CPU, and it'll run there. Okay, so the compiled code, it basically is pre-made code that only the machine can execute, and you can't modify it, right? You can't modify it. So that's the big difference between Linux and Unix. And let's take just a few moments to look at, and we have a few minutes because of the install. I'm going to put up here just a quick video from Linux Foundation about the history of Linux. Oh, this might.
Our story begins 20 years ago. Boris Yeltsin.
You know what happens here is I need to cache it for just a moment or buffer it, and we'll start up with this video.
Hey, it's Al Gore again.
Yeah. Yes. All right. Very good. We'll stop by right there. Very good.
Sworn into office. Jay Leno played Johnny Carson on the Tonight Show, and cell phones
All right.
was really
We're back in
It was August
over again.
1991.
Let's go to
and a
boot
20-year-old
and make it
computer science
500.
student named Linus Torvalds sat down at his computer in
Yeah.
Helsinki to post what is now one of the most famous entries in computing history. Hello, everybody out there. I'm doing a free operating system, just a hobby. It won't be anything big and
That's fine.
professional like GNU.
That's perfect.
It probably will never support anything other than AT hard disks, if
Great.
that's all I have. We're a Linux open source project that is spread around the globe, and developers from all over contributed their code. Linus named his
No,
OS
no.
Do the
kernel
swap.
Linux,
No, that's
and
right
chose
here.
a penguin as its
Do the
mascot.
swap.
Yeah, right there. Perfect.
Mascot. After a little ads that are good.
Exercise
He
2000.
soon
Yeah.
made a very important decision that would shape Linux's future just as much as the technology. He chose the GPL license created by a visionary named Richard
let's
Stallman.
flip them
The
over.
Linux
So
kernel,
boot will be
along with the
500 and swap
GPL
2000.
license and other GNU components, revolutionized the computing
Let's
industry
create.
with a very simple yet
And,
very
yeah,
important
root,
freedom.
first one.
The freedom to use the software
Drop
for any
space.
purpose.
And 500
The
right
freedom
here.
to change the software to suit your needs. The
Perfect.
freedom to share the software with your friends
Great.
and neighbors.
Let's see
And
next.
the freedom to share the
Okay,
changes
wait,
you
wait.
make. These radical ideas
Okay, let's
fueled
do
and spread around the
that.
world, and somewhat paradoxically, its rise from a
All right,
hobbyist
then go ahead.
experiment to the foundation of a large and private
It's
commercial
perfect. Say
ecosystem.
format.
Company.
You do format.
Mm-hmm.
That's how the MS-DOS. That was our pride.
Sorry about the buffering. Yes.
He's built businesses around Linux.
Yep, that's fine. See, okay.
In 1999, Red Hat's stock tripled as it became the first Linux company
Yep.
to go public. That same year, IBM
Yes.
spent $1 billion to improve and advertise Linux.
Perfect. Yep, yep. Let me create again.
Soon,
Great.
Linux was knocking out industry heavyweights
And then-
fueling the rise of the internet with its
Root, the first one. The first one. Yep. Yep, I say okay.
free software. In short, Linux revolutionized computing.
Okay, let's go back here.
But whenever something is this
No,
disruptive,
let's
there's
go back to
bound
root.
to be
Yeah, double
competitive
click on the
crossfire.
root.
But Linux not
Double
only
click.
survived, it
And
thrived.
select
Today,
row
the
space,
kernel development
500 right
community
here.
numbers in the thousands, with hundreds of companies collaborating on
Perfect.
Linux
Say okay.
development. Every 3 months,
All right,
another
and say
version of
next.
Linux is released.
Say
So,
format.
where is Linux today?
And right to change.
Running in
Okay,
75%
great.
of
This is
stock
perfect. Say
exchanges
next.
worldwide.
Yeah.
And
Go ahead and
powering
click on it.
servers that deliver
Okay, good.
Amazon, Facebook,
Say-
Twitter,
say
email,
next.
and Google. You use Linux literally every time you surf the internet.
All right,
It's
per-
in your
per-
phone,
perfect. Let's go next.
in your TV,
Yeah,
running
say next.
95% of supercomputers, and in
All right,
many of the
very good.
devices.
I blame my internet.
What's that?
I blame my internet.
I did too. Are you okay?
Transfer, but I think I missed it somewhere in there.
Okay. Okay. When you get there, let me know and I can help you with that. Yep.
Army of developers from his home office. He reported
Looks
with
good.
As a fellow
Yeah,
at
but
the
I
Linux
missed
Foundation.
all the partitions.
As we
That's why I
celebrate
was
20
wondering,
years
is it
of
okay?
Linux, we can all see ourselves.
All right. Looking good. All right. Great.
Is there any way to lock the cursor in here?
How do you want to lock the cursor?
Like so that I gotta push control to get out of it.
Well, I think if you cancel this.
Oh, is that what's doing it?
I think so.
Okay.
But
Do we
listen,
need
I
this
don't.
right
No,
now?
it's not going to work. Just cancel it because you don't have the rights to install it. Yep. All right. So. All right. All right. So in this video, it talks about the story of Linux, which is important. Okay, it's important to know where Linux came from because you can hardly think about how a small group of developers could change this very expensive and successful industry of computers. Okay, which means that really there are great opportunities for people with ideas. There's great opportunities in open source especially. The market is very much saturated for, I think, for commercial products that basically, just create something and now people will buy a whole lot of it. But the opportunities are great for having an idea, creating an open source version of it, and then having people start using it, and then creating services around it. Firefox would be a great example of it. Okay, everybody's using it, well, or they should at least, on a Windows system even, right? It's open source. It's more secure than the competitor from the native operating system. It's very innovative. I mean, think about the first time you saw tabs, and some of the browsing systems. I should say that there's another browser called Opera that actually innovates probably even better than Firefox. But yet, Firefox, because of being open source, is very, very popular. Anybody knows of other open source projects that are successful? Okay, Android. All right, now Android, I have personally a bit problem with them. For one, I'm sort of an iPhone person, but Android has patents in it that belong to Microsoft. So for every Android device that you buy, some money goes towards Microsoft. So it's not, even though it is sold as an open source system, it is not a straight clear-cut open source. Any other, but it is very successful. I agree. Any other projects that have been successful?
My favorite is VLC Media Player.
Okay, great media player. Yeah. So on the Mac especially, it works nicely. Yeah. Please. OpenOffice, yes.
OpenOffice is a big one.
All right, so if you think about it, the same company that has VirtualBox, which will Sun Microsystems, now Oracle, they sort of care for OpenOffice, even though there are different approaches to that. The key with OpenOffice, though, is that it'll edit, of course, Microsoft Office files, but it'll do more than that. A beautiful project. I use it all the time on the Mac. I use it on Linux. I use it on the Windows system. Any other projects that you found successful?
I'm
Please.
not really sure. Is Google Chrome an open source?
I don't think it's open source. No,
Open source?
no. Go ahead. Yes, it is.
I know it's commercially licensed.
Well, MySQL or MySQL is a Scandinavian product that started dual licensed. So there's a community version. You can have it open source, or if you like support, you pay for it. Today, Oracle owns MySQL, and so there are some questions of where it'll go. But it's another beautiful example of a database that took over the internet. I mean, really, that's what happened. Most of the great projects like Facebook, even Google, they all started with MySQL backend. God knows what they run now on the backend, but that's what they started with. Okay. How about? Have you ever heard about Binder? Oh, maybe I have that wrong. Elephant's Dream. Binder. Blender. Elephant's Dream is a movie that you can look at, a few years old now, but it was created with open source 3D animation tools. Okay, and Blender is the software, and by now there are all kinds of examples of movies created with it. Okay, there are other commercial products that do 3D animation. Okay, but this you can use at home. You can start looking into that. Okay, really cool stuff. How about let's see, the one that does what Photoshop does. GIMP, thank you. Yes, GIMP, right? Now, my wife says that it doesn't. She is an designer type person, but I swear everything I ever wanted to do with pictures, I can do with GIMP. You know, you can do layers, you can do all kinds of transitions and things. So GIMP is another nice open source project. How about Audacity? Audacity allows you to edit music. I think you can edit MP3 files and other ones like that. Audacity. How about Handbrake? Okay, Handbrake allows you to legally make a copy of your DVD movie, and it works perfectly too, especially on the Mac. It works great. A list is really long. I think we're still looking at. Okay, so here's our install. Is everybody that is install completed now? Still going? Okay, good. Okay, I still see a few of them going. Let's wait with this last button. I want to show you a quick video that comes to us from CompTIA. CompTIA is a company that specializes in creating short-term credentials in a very vertical technology. So you can get certified for A+ from CompTIA as being a technician. You can get certified for Linux Plus, which again gives you that kind of snapshot in time, because I think that it speaks well to the technology industry in general.
Get a certification that will help you get
Wake up.
that job. Certification helps increase job security. Certification provides advancement opportunities.
Oh, you know what? They went.
Recognition and
Sorry about it. They went to the wrong chapter. I don't know why I jumped there.
They really want us to be certified.
We do. There is a business model behind it. Okay, let's not kid ourselves. But in general, if with an associate degree, if you can add certifications to that, it does increase your visibility, and it shows a credential again in a specific vertical technology.
information technology is everywhere. Choosing a career in IT can give you the power to help shape the way the world connects. Whether you're interested in music, retail, medicine, government, mobile technologies and gadgets, or want to see and change the world, companies in all industries depend on skilled IT employees. Did you know more than 15 million young professionals work in this fast-paced and growing field? And more than 1 million IT workers got their start with CompTIA? As a non-profit association for the IT industry, CompTIA can help you begin your career. For more than 25 years, CompTIA has been helping students who are just starting out with the right tools they need to enter the growing IT workforce. CompTIA's Education to Careers program provides benefits and discounts to member schools and their students. You may be eligible for certification programs through your school that will help you land that first great job.
And that's business.
Right, there's a business, but if you put yourself in the shoes of this HR person or a manager, you know, they may see a number of bachelor degrees or associate degrees, some of them old, you know, so certification then show, okay, for this specific job, you know the latest
Whether you
version.
attend high school, community college, university, or trade school, you can learn new employable skills to land an IT job in many different fields. Get a CompTIA certification through CompTIA's education program. A certification is an actual test of knowledge, proof that you have learned and understand baseline IT skills. With this authorized certification on your resume or job application, potential employers know that they can depend on you as you start a new job to get up to speed quickly. CompTIA offers many certifications covering different vendor technologies and systems. Many of our certifications are stepping stones and prerequisites into advanced certificates and careers. CompTIA certifications include A+, Network Plus, Security Plus, Project Plus, and more. In fact, CompTIA certifications are the best way to get trained and tested as a new IT professional. CompTIA A+ got my foot in the door. It made my resume stand out. I am very happy with the way things have ended up career-wise for me. A few years ago, I never thought I would be where I am now. Industry experts and employers expect there won't be enough trained IT professionals to fill open jobs. Getting certified can help you land a well-paying job. For example, people certified with CompTIA A+ say their annual starting salary earned them as much as $66,000 a year. Not bad. Get a certification that will help you get that.
All right, so we'll stop it right here. And the reason why I'm mentioning this is because in IT there are so many different technologies that, again, it's hard for the manager sometimes to know when you say on the resume, I have experience with Linux or I know Linux, what does it really mean? So here at least it means, okay, you passed the 2 tests that it takes to do that. And again, our textbook and the labs are geared towards this certification. So that's the good news. Let's go back to the lab, and if you're looking at the screen for reboot, go ahead and press the key. Virtualization is playing a trick on us here in that on a regular computer, when you leave the CD in place after completing installation and then you reboot the computer, it'll restart the installation program. Okay? VMware is smart enough to try to correct it for us, so they already went in the BIOS and they made the change from CD-ROM boot into the local drive. It's a shortcut that it takes a while to get used to, because if something went wrong in the installation, you have to go back to the BIOS to modify it to restart the CD boot, or you have to recreate the virtual machine. Okay, but right now we're booting into the Fedora system. If you're running Fedora 13, that's fine. Fedora 14 is what we have local. I believe 15 is now available for download. Is it on the side? Okay, so you can see that with Linux, sometimes the versions can go really fast. But with Red Hat, for example, again, they hold the versions fairly steady, which is great. All right, from here we say forward. There's a discussion here about the new or the general public license. We'll say forward on that. And now it's time to create a user ID. Go ahead and create a user ID that you please. So it's really up to you what you create here. We'll say forward. Yes?
Password.
Yep. It's up to you whether you synchronize the date or not. It's optional. I'll say forward without that. And please do not send the profile because we're going to be hibernating our systems and we'll be doing different things to it. It's not necessary to bother the good people at Fedora with our problems. So we'll just say do not send profile. We'll say finish, do not send. And now you're done installing your first Linux system. Okay. You can double click on your username, put in the password that you just created, and now you are at the desktop of Fedora. If you recall lab number 1 through lab connection, it uses these very menus, right, the first lab. So you can see how this virtualization is full hands-on, where you can go and explore, you can destroy if you want to, it doesn't take that much to reinstall it. You can copy this virtual hardware. You see, this virtual system, the entire thing is located in a single directory. If you look on the computer on the C drive, you don't have to do it right now, but on the C drive VM images, see, I have the entire system in single directory. If you make a copy of it, then you've just copied the hardware and the software to a different directory. You can mess up the original one, you can get a virus, you can do whatever you want to do, and then you still have a working backup. It's beautiful. I mean, I love virtualization for that. Okay, and so these are the menus from the first lab. One thing I'd like you to do today is to right-click on the desktop, go to Change Desktop Background. This is like the funnest thing to do on the operating system, right? You look at what backgrounds came with it. Go ahead and explore those, and then click on Get More Backgrounds Online. And what you'll notice is that this button is going to take you to the art.gnome.org. If you get the message that I am getting, it means that our networking did not connect correctly. And that's because the two computers at the top next to the clock, okay, we're not connected to the network. We click on the two computers, they have a little red sign. Click on the computers, say System ETH0, and that's going to connect you to the internet momentarily. And then all you have to do is just click Enter to get to refresh what the browser is doing. Okay, is it working for you?
No, I just accidentally hit exit out.
Oh, that's okay. You can go right back to it by going to Start.
I clicked on it already.
Oh, you did. Okay, you're recovering. Good. Yeah, you should be able to double click on that. Yep, and just say skip this version. That's fine. Yeah. Oh, you're already playing games. All right, so you're way ahead of. You're in chapter 4. Okay. All right. So great. So this art.gnome.org allows you to download themes, icons, all kinds of things. Perfect. You're in the right place. Push the play button right here. Do that again. Okay. Go ahead and click on this computer and then select System ETH0. No, this one right there. Perfect. It'll load that up, and then you just click on the green there again. There you go. Perfect. Now you're getting. Looks good. Say finish. Yep, and say do not send. Perfect. Okay, so this virtualized system, you can do it at home, and it gives you full hands-on the system, right? The lab connection labs are limited. They have specific goal with every lab, so you can only click on certain things. But they sort of lead you through step by step. You can go back to the virtual system and then explore whatever is around it. If you want to, you can have both open and just follow in your virtual machine what the lab connection does, right? Okay, all right, great. So good, you're logged in. All you need to do now is just click on the little computer here and do a left click for me on this. Yep, left click, and then System ETH0. Perfect. And now you can right click on the background, say Change Desktop Background, and there are some images that will come up here momentarily, and then you can click on Get More Backgrounds Online. Yeah, perfect. All right, so was that exciting? All right, good. New stuff, huh? You see, that's what you're doing right now. You're creating a new universe, all right? It's not just a new tree or a new program that's going to run in a different environment. It's a completely new environment, universe you're creating. You can have games inside, you can have servers, you can have all kinds of stuff inside, and that's beautiful. Okay. Okay, well for today, let's go ahead and stop right here. By stop, I mean I'll stop talking, You can take your time to explore the virtual machine. You can take a closer look at redhat.com, at fedora.org. All those locations are going to be a nice introduction. The one thing that I do want to mention in addition is that I tend to use Twitter. The account, so twitter.com/grccprof, and that's typically how we'll start our classes. But I tweet with tag CO232, and so that's for our class. And so when I find interesting things about Linux, I'll share those through Twitter. So you can create your own Twitter account and then set this information to come to your phone, or you can just create an account and just follow the account to get the updates. You can actually set Twitter to email it to you if you wanted to. But some of the things that that I marked recently on CO232, I actually marked those IBM commercials. I think I shared some things here recently about Firefox. Let's see. Yeah, so basically that's how we can stay in touch, and even once you complete the class, you can continue to get updates on new things that are taking place. There is a new Linux device. That's what I was looking for. It has to do with a Raspberry. Where's my Raspberry device here? $25 Linux, where did it go? There it is. So there's a new device that costs about $25, and it's capable of running Linux. It's just a small board that you plug into a TV and a keyboard, and it's called a Raspberry Pi, and that's how big it is. There should be a picture of it here somewhere close by. It's probably right on their home page. You can buy these devices now on eBay. There it is, an example of it. There should be a bigger picture. There it is. All right, so that's small of a board, and it has the CPU, it has the memory, it has the disk, all of it. Okay, that's small. Many Linux systems are distributed today as appliances. Basically, you take a small computer and you create a network device out of it, or a firewall, or an application firewall. So Linux becomes sort of the embedded system that does all kinds of different things. All right? Okay, well, thank you for the discussion today, and your patience with the textbook, and also our slow startup. If you have any questions, feel free to ask. You know, stay after. For next week, we have Chapter 3. So go ahead and to be caught up with next week, I'd like you to read Chapter 3 so that we're ready to tackle that. But by the next class, please complete the Lab 1, which is fairly short on Lab Connection, the Lab 2, which is observation of installation. You already are ahead of that because you've done one by yourself. And then we have Test 1 and Test 2. Okay? Any questions? Okay, great. Next week is going to be another great class, and we'll do more with Linux. Please.
Are we to complete Test 1 and Test 2?
Yes. Yes. Yep. Yep. Yeah, taking tests is fun. I'm glad I don't have to do it. So, all right, very good. If you have questions, feel free to come up and we'll talk.